Welcome to session 4 of Quality Assurance equals Common Sense, or the best quality assurance equals common sense. And we're going to focus on Excel today, where it's still really important that you apply common sense. So what we're going to be talking about first is particulate matter data gathered on, the particulate matter was gathered on filters, and it was weighed by our own Tribal Air Monitoring Support Center weighing laboratory, and they call this a gravimetric laboratory. And this is a picture of a report that Alfonso Macua received from the laboratory with the filters. So we're going to go from this report, where they have provided the weights of the filters before sampling and after sampling, to putting it into Alfonso's template, where he has his data that he's been gathering over the months, and he's plotted it out, and he wants to add data to his chart and compare it with his other values and with the limit for PM 2.5, which is 12 micrograms per cubic meter. So how does he get from this exact, he emailed me this form that he gets from the laboratory that shows the filter number, the tare weight, which is the weight of the filter before it was exposed, and the final weight, which is the weight of the filter after he exposed it in his sampler and shipped it back to the lab to be weighed. How does he translate that into concentration in micrograms per cubic meter and plot it in this plot with all the rest of his data? So first of all, let's make sure we can make sense of the report from the laboratory. So the laboratory reports, depending upon what laboratory you use, are going to look a little bit different, and everyone has their quirks. And what you see here is the COC, or chain of custody number, and that's the form that Alfonso used to record all the information about these filters that then he shipped with the filters to the lab. So when they got them at the lab, they would know exposure date and what kind of filter it was. So you could see that he's got these filter IDs, and they end in 04, 05, 06, 07. These are the dates they were exposed. And then he's got one that's a field blank and one that's a trip blank. And when I say exposed, I mean that they were put into the sampler, then the sampler was turned on, and then the sampler sucked air through the filter, and the particulate matter that was in that volume of air that was sucked through the filter over a 24-hour period gets stuck on the filter. So the field blank and the trip blank were not put into the sampler, they just accompanied the filter. The field blank, he actually opened up and put it in his mini vault and then took it right out. And you can see that that one actually lost a little bit of weight. And we'll look in more detail at what these numbers are in a minute. And the trip blank just accompanied the filter. If you remember from the last session, a trip blank just accompanies whatever sample that you're gathering to determine if there was any contamination that got on that sample, in this case a filter, during the whole process of going out into the field, taking the sample, and shipping it to the lab. Because stuff can happen in the UPS truck or in the Federal Express plane, or however your filters or your samples get to the analysis lab. So you've got the filter number here, and you've got two that were exposed on the same date, and that's because Alfonso has two side-by-side mini vols where he is looking at the particulate matter on the two filters, and since he's got two, he's going to end up taking the average of the two for his best estimate of what the truth is for the particulate matter concentration at this site. So let's look at what these values are. So the tare weight, again, that's the weight of the filter. What the lab does is they go out and they buy filters. There are special filters. They buy them. They've got little tiny numbers on the edge of the filter, and they weigh it when it's just clean, straight, brand new out of the box. Then they package it up and ship it to Alfonso. He takes it, he puts it in his sampler. He sets up the sampler to run for exactly 24 hours at 5 liters per minute in this case. Different samplers run at different flow rates. And then he comes back the next day, gets the filter out of the sampler, ships it back to the lab. They weigh it again, and now it weighs more because it was exposed to this particulate matter that stuck to it. It was filtered out of the air basically onto the filter. And you could see that this 392.925 milligrams, it's not too much more, but it is higher than 392.885 milligrams. Well, the laboratory says that this is a difference of 40 micrograms. Well, first of all, before I say, is that right? I can't do that in my head. I am not going to fool around with this sheet right here. This is the exact sheet that I got from the lab. Now, in case I mess this up, I can go back to my email, right, because they emailed it to me, and I can get it as it was sent to me as an attachment. But I don't want to have to fool with that. This is the data. I am going to not do anything with this sheet. So the first thing I'm going to do is copy this whole sheet over into a new sheet that I can start fooling around with, and then I don't have to worry about messing up this sheet. So the first thing that I'm going to do is copy this whole sheet into a new sheet. So what I'm going to do is select this whole sheet. Now, first of all, let's just do a review of what these different rectangles in Excel are and how Excel labels them. So if I click here on this first tare weight value, what is shown up here, this is in the formula bar, and it shows what's in this cell. Now, the lab has formatted this kind of funny, where they formatted this to show milligrams after, and you can see that the actual value is 392.885, and it doesn't have that milligrams in there. We're not going to worry about that right now. I'll show you how to take care of that in a minute. But this, when you click on this, you see how the D gets yellow, and then over here the 3 gets yellow? That's because this particular cell is identified by its column and by its row as cell D3. If we click over here in A1, the A is yellow and the 1 is yellow, and then here in the formula bar is shown what's in this cell. So what we want to do is copy everything in here into a new sheet. And you can see down here at the bottom, Excel has tabs. And I think you can have like 6, I think you can have actually about 120 sheets in a file. So what we're going to do is copy this whole sheet into a new tab, and you could create new tabs as many as you want by clicking down here on the last tab, which shows like this little tiny asterisk, and you can just keep clicking, and then you've got all these new tabs in here. But what we want to do is select this one and select everything in here. Now you can select an entire column by clicking on the header. You could select an entire row by clicking on the row, but we want to select the entire sheet. And the easiest way to do that is to click on this gray intersection box up here in the upper left. And you can see that the whole thing is selected then, because all of the column headers and the row headers get that blue look, and as the whole sheet does, and we know it's selected. And now we're going to say copy. So I'm going to click up here, copy, and now you see it puts these blinking Las Vegas lights around the whole selection of the whole sheet. So you know it's in the clipboard, and I'm going to go over here to sheet 1. So I'm going to click on sheet 1, and now I'm going to click on this whole sheet so the copy and paste area are the same. And now I'm going to say paste, and this time I'm going to do something tricky and paste values. And that way I have just pasted the values and no calculations or formatting. And how I did that again was paste values. And that way you get rid of any formatting that's weird to you. You've got to also be careful sometimes because you are not pasting the formulas. So what I want here is just absolutely raw data from the lab, and so that's why I pasted values into this sheet. Now what I'm going to do is I'm going to rename this sheet. So what I did is I clicked on this sheet number down here, and then I right clicked, and then I say rename, and then it's black so I can type in a new name, and I'm going to type in working underscore data. And that way I will know to leave this first sheet with the raw data and the formatting just exactly as I got it from the lab alone, and I'll always work from this working data. So now I want to see, is this really a difference of 40 here? Is this really a difference of 34? So I'm going to demonstrate inserting a new column and inserting a formula to do this calculation. So whenever you want to insert a column, click in the cell that you want the column to be inserted to the left of. So I want a new column here where I'm going to take the final weight minus the tare weight or the initial weight, and I'm going to calculate it and make sure that it really is 40 micrograms. And what does that mean? So actually I'm going to click here. So I want a new column in here in between E and F. So I've clicked there, and then I'm going to go up here to the menu bar. I'm going to say insert column, and I'm going to type in net weight milligrams, because I know these are in units of milligrams. So I'm going to click in the cell where I want the answer to be, and I'm going to type in equals the final weight. So I clicked in cell E3, and then it shows the blinking Las Vegas lights showing what is over here. And it, since I just clicked on E3, it types in E3 for me, and then I'm going to hit on my keyboard minus, which is to the right of the 0, minus the tare weight or the initial weight. So I click here and it types in D3, and then I hit enter, and then it calculates the difference, and it says 0.040, and that's the answer in milligrams. Now I want to know what the next one is too, right? So when I have this cell selected, you see it's got this black border, and in the lower right it's got this little black square. If I put my cursor on that black square and it turns into a black cross, I pull it down and it will copy this formula all the way down to the extent to which I've dragged it down. So let's look at what it's done. Okay, E3 minus D3, and I can tell what cells it's talking about more easily. If I click up here in the formula bar, then it puts them in color, and it shows not just the answer here, it shows the actual equation. And what I like about clicking up here is that it puts it in color, and I can say, okay, so it's the blue one, which is shown blue here, E3, minus the green thing, which is D3. That's what I want. So I've checked that equation. Now let me see if it copied down right. So I'm going to click enter. If you are in the formula bar and you do something weird and you mess it up, just hit escape, and that will take you out of it and negate anything that you might have done to mess up that formula. So I just hit escape, and then it went back to just showing the value here. So I'm going to click down one and see, did it copy, did it really subtract the right things? Well, to see it more easily, since I'm so color oriented, I'm going to click here and I can say, okay, look, E4 minus D4. So it copied the formula down, and what Excel does is it says, okay, I'm going to assume you want the same pattern for the formula copied down. So it says, all right, I want the one to the left minus the one 2 over to the left. And it keeps copying that down. So I'm going to hit escape and get out of that and look at this next one. This one's negative. Well, yes, it is negative because the final weight was a tiny bit more, or tiny bit less by 0.002, right? 386.249 minus 386.247. Hit escape, and I see, yeah, the final weight was actually a little bit less. Well, if you remember, this was a field blank, so Alfonso took this filter, he took it out of its case, he put it into his mini ball, then he didn't turn the mini ball on, he immediately took it out and put it back into its case. Well, nothing wrong with what Alfonso did, but you could see even in that little bit of touching it, it actually lost maybe like some little fiber off the filter or something. But it also could be that this is within the margin of error of the laboratory scale, right? You're talking about incredibly tiny, tiny amounts of mass. So maybe this is just like the scale. You know, when you go to weigh yourself in the morning, you think, oh, gee, that must be wrong. So every scale has a little bit of variation in it. And that could be within the variation of the scale. Now his trip blank, that just accompanied the filter. That one stayed exactly the same, and it has a 0 change in mass. So nothing happened in the trip. He did all the packaging correctly. The UPS man didn't do anything weird to the filter. It is exactly the same as when the lab sent it to Alfonso. So now these are these are the values in milligrams. What did the lab mean when they had this column over here, net weight without a unit? Well, we know it probably is micrograms, right? So just to make sure and compare, I'm going to insert another column. So I'm going to say insert sheet columns, and it inserted it just to the left of where I was. And now I'm going to call this net weight micrograms. And now I'm just going to take this value. If you remember, every milligram has 1,000 micrograms in it. So in order to convert from milligrams to micrograms, I multiply by 1,000. So it's like to convert from a foot to an inch, you divide by 12, right? So what I'm going to do is I'm going to click in this cell where I want to do this to convert from milligrams to micrograms, and then I type in equals. And if you notice, right now up here in the formula bar it's blank, but as soon as I type in equals, then the formula bar has more things up here because it says, ooh, how exciting, she wants to put in an equation. And we'll talk about the different sorts of things that you could calculate, but right now we just want to convert from milligrams to micrograms. So I'm going to say I want to take, so equals, and then I'm going to click in the cell where I want to start the calculation. So I'm going to say I want what's in column G to be equals to this value on the left from column F times, and that's the asterisk which is above the number 8, times 1,000, and then enter. And you can see it already does it in color. There's only one variable here, but it's shown in blue. So it says, okay, you want this value to the left times 1,000. Hit enter. Yes. And that's the value in micrograms. Now again, I want to convert all of these over to micrograms. So if I click on that, you can see it's got this, and it's called the autofill handle. And when I put my cursor over it, it turns into a black cross, which means that I can drag this equation down, and I don't have to retype it in all the time, and it will do the same calculation copied down. And if I click in this second cell, just to make sure it did it right, and then I click over here in the formula bar, it shows the cells that the calculation is being done on in color. So yes, it said, okay, Melinda, you want the cell to the left times 1,000. We're going to just keep going to cell to the left times 1,000 and put that in this new column G. So I hit enter, and now you can see, all right, I've double checked what the lab's calculations were. Now I understand that they mean that these values are in micrograms. Okay, so now remember, we have to calculate the concentration, and the concentration is the micrograms per cubic meter. So now let's look at what Alfonso has been doing, which is this data sheet here, where he's been over a year been gathering data using these mini-vols, and he wants to add the data here, and I've made these blue so we can see, so that he can add the data to his ongoing chart where he's looking at the concentrations of micrograms per cubic meter over time, and he wants to add this newest data to this and have it populate this chart. So what he's done here is, just looking at this, you could see he's got different filter types. So he's already put in, I'm going to scroll this to the top. Now that's nice that it shows the header. I'm going to show you how to do that. First of all, see when you scroll down and you've got a lot of data, what's nice is to keep your header rows showing so that you know, well, what is this column I'm in? And you can see what the label is for at the top of the whole column, what that column represents. How you do that is you go to View, and then there's these options here including Freeze Panes, and if you put your cursor over it, it shows a tooltip. All of these show a tooltip. Some of them are more explanatory than others. But if you click Freeze Panes, and then there's a down arrow, so there's different options. I'll show you if you unfreeze the panes, and then you scroll down, you think, okay, that's date clearly, but what's this number over here, and what's that number over there? It's really nice to be able to show these all the time. So if I click here, Freeze Panes, and then Freeze Top Row, then when I scroll down, that top row is showing. So I'm going to scroll down to the beginning of this blue. So what Alfonso did is he put in, this is chain of custody number, so this is this piece of paper has a number where he put the information from these filters, and when he exposed the filters, he went ahead and added that information to this sheet so that when he got the results from the lab, he would be ready to go. So he's got these filters, because it takes a few weeks at least to get the data back from the lab. So he has blanks here for tare weight and final weight because he doesn't have that, and the net weight is 0 because he doesn't have these yet from the lab. But he knows what he did in the field, so he went ahead and put in the flow rate of 5 liters per minute that went through his sampler. He did a calculation of the total time because he knows that he set it to run for 24 hours, and some of them don't run for exactly 24 hours, but in this case they did. So he's got the number of minutes, and you can see it shows 1,440 in this cell, but the calculation is shown here as 24 times 6. The calculation is 24 times 60 equals 1,140 minutes. So he's already got that in here, and he even has some other filters that he has already gotten the results from the lab back here already. These are results of field blanks and trip blanks. But he just got, let's just assume he just got these values from this chain of custody sheet for these filters exposed in November of last year. And now he's got to copy in to this template where he's got all this data and his chart, the values that he just got from the lab. So how does he do that? Well, let's go back to the data report from the lab. Now remember, we're going to be working from the working data tab, not the raw data that he got from the lab. So we've got here tare weight and final weight and net weight. Well, all we need to copy over are tare weight and final weight because the net weight is calculated in his template, I believe. Let's find out. So we're going to copy these values, and we're going to also be real clear and double check them. We're looking at filter numbers that end in 04, 05, 06, and 07. So I've selected this block of cells, and you could see the D and E showing it's selected in columns D and E are yellow, and 3, 4, 5, and 6 showing the rows of where the selection is. Now I'm going to say copy. Wait a second, where did copy go? All right, I go back over to the Home tab here. And you can also right click and say copy, but just to demonstrate the menu bar way, I'm going to click copy, and then I'm going to go into the template where all his data is, and I'm going to carefully check. This is filter 04, 05, 06, 07, and then tare weight and final weight. So I'm going to select the same footprint of 2 columns and 4 rows right next to the filter numbers, and now I'm going to say paste, and I'm just going to say paste. And then you can see, boop, right away the net weight was calculated, and it's the same calculation because if you click on it, you could see what is that calculation. It shows up here. I'm going to click on this, and it shows, okay, it's the blue value minus the green value times 1,000 to go from milligrams to micrograms. And it did the calculation, and it's got the same values that the lab calculated, and we double checked of 40, 34, minus 2, and 0. But we're not going to plot the field blank and the trip blank. These are QC checks, and it's good. They're right around 0, and they're within the margin of error. Our limit, our QC limit for a field blank, I believe, is 3 micrograms. So we're within the QC limit for how much a field blank should deviate from 0. So what we're interested in are these 2 values and adding them to our chart. But before we get into that, let's look at how the calculations are done. So for this one filter here, we're looking at that ends in 04. Well, now we've got the net weight in micrograms. How do we get from micrograms to cubic meter? Well, let's see how we calculated cubic meter first. And Alfonso already did this. So let's click here and see how he got this 7.2. We went over this calculation in the 3rd session on PM. But it's redone here in this column because it might not be exactly 7.2, right? If his sampler didn't run for exactly 24 hours, or maybe it was not right at 5 liters per minute, maybe it was 5.1 liters per minute, or whatever, it might not exactly be 7.2 cubic meters. A 7.2 boxes full of air pass through that little filter. So this calculate, we click up here to see the values in color, and we say, okay, how was that calculation done? Well, the flow rate in liters per minute, right? And then how many minutes? So that's these 2. So the flow rate went through for 1,440 minutes at a rate of 5 liters per minute, and then you know, okay, that's how many liters, the 2 multiplied. But then that gives you liters, right? And then you have to multiply by 1,000 because we know that there are 1,000 liters in one of these square boxes of a meter on the side. So I hit enter or escape in this case because I want to make sure I don't mess up this. And it says, okay, 7.2 cubic meters. Okay, how do I calculate concentration? Well, the formula is already in here. So as soon as we typed in, or we copied in the tare weight and the final weight, it calculates this concentration. And let's click here in the formula bar, and it shows that you took the green value, or excuse me, the blue value, slash, which is divided by the green value, which makes sense, right? We know concentration is in micrograms per cubic meter, so we took the micrograms divided by, or per cubic meter, and that gives us 5.6. I'm going to type in the units here, and I'm going to use that shortcut U grams per M3 for micrograms per cubic meter because I really like units to be shown so I know, am I talking about milligrams, micrograms, pounds? What am I talking about? Now that went up, so let's scroll back down so we can see this more easily. So now we've got our two side-by-side values that were exposed on the 10th. And what we really want to plot is our best estimate of the truth, right? These two are pretty close to one another, but we want to plot the average. So we know these were just side by side, the exact same time, so we're going to take their average and put that in our plot. So how do we do that? Well, let's click over here. This is the average of duplicates column, and you could see if you click here, it shows you, okay, it takes the average of these values here, K17, and you could see that colon there. This means a range, everything between K17 and K18. And what's nice about Excel is it also shows you in this picture, enclosed in blue, K17, so column K, row 17 through row 18. So it's just these two cells, and it takes the average, and that's what's shown in this average of duplicates. So I hit enter or escape if I think I may have messed that up, and that's the average. 5.1 is the average of 5.6 and 4.7. So did that add to our chart? So now you can see, because I've scrolled down, this chart is all squished over here. So I'm going to scroll up and we can see the whole chart. Then I'm going to pull this over a little bit so our chart's more in the middle of the screen. And now we're going to talk a little bit about what this chart means. So first of all, in the summer webinar series on Excel, we're going to talk about how to make such a chart from scratch. But in order to just demonstrate a few key features of it, and because Alfonso already had this chart that we just added data to, I'm going to show you where this went in this chart and what it means. So first of all, you could see that there is on the x-axis down here date. So we've got data from last May all the way through the end of November of last year. Where did our data point go? Well, if you hover your cursor over these data points, it will, and click just and put your cursor there, then it pops up information about that point. Just to make it easier for you guys to see, I'm going to hover over this one here. So this one is saying, this is from the series called Average of Duplicates, and how Excel thinks that's a series is because that's my header there. If you look in row M, Average of Duplicates is the header, so Excel says, okay, I guess I'll label it that unless she tells me otherwise. This is the point 07/02/12 from July 2nd, 2012, and that's how Excel identifies the point by what's on the x-axis. Oops, come back here. And then it gives you, in parentheses, x, comma, y. So what we've got here is the x value, and you can see on the x-axis are dates, so that's x. So this particular point, in terms of x, comma, y, is the 2nd of July, 2012. So if we take a line down here, it will hit the x-axis right on July 2nd, 2012. So this point is identified by where it is on the x-axis and then where it is on the y-axis. So it says x comma y. So July 2nd, comma 17.43, and then it's got a lot of significant figures, and that's because Excel keeps that information even though it's not actually displayed in our column, and that's just a formatting thing. So if we go over here to the left, we will hit the y-axis right at 17.4. And I could add in more grid lines and we could see, yeah, 15, 16, 17, 18, 19, 20. So this point here is actually this point over here. You see right here, 7.2 and 17.4. That's this point right here. Now, if you want to get fancy like I did here, I added a label because this is a pretty high point. And so when Alfonso is doing a presentation, people might say, well, what happened on that day? What day was that exactly, and what is that value? And for some of the high values, it's often useful to add a label so then you know right away, and you don't have to say, okay, what is the date? And then take a line down to the x-axis that you say, well, it looks like maybe it was the 19th, around there, a little bit before the 20th, and you see. You can also hover your cursor over it, but if you've copied this into a PowerPoint, you wouldn't be able to do that. So that is because I added this label here that it shows. So another thing that I wanted to show you is this limit line at 12 micrograms per cubic meter. That is plotted in the chart because I've added this as a series, this limit here, in this column where I've got 12 micrograms all the way down, and so it plots it, and I've changed this so instead of just showing all these points, it actually shows this as a dotted line, because people are always wondering, well, is this data greater than the standard or less than the standard? So just to show you how, for example, if you wanted to calculate the average of duplicates. Let's just say somehow this spreadsheet got messed up and this calculation showing this point was eliminated. I delete that and that goes away in the chart. The chart will automatically refresh with your data as long as it's in the same sheet and you've set it up so that it's pulling from the data and it knows clearly what data is supposed to be plotted in the chart. Excel is easily confused, and that's always the problem. Whenever something doesn't work out the way you want, it's probably because Excel is confused. So I need to redo that. Well, I could always hit the undo button, which I love, the undo and then redo button, but I'm going to type this equation in again. So in order to calculate the average, I type in equals, and then Excel says, ooh, she must mean a calculation. So it now shows up here on in the formula bar more of these that pertain to calculations. So I know that the formula for average is equal average. So I could just type in equals average, and then some things pop up. Well, you could see it says, ooh, do you mean average, average A, average if, or average with multiple ifs? You can click one of these, and then what's nice about Excel is it shows you what arguments you need, and the arguments are basically what has to go into the equation, and it does an open parentheses for you, and then it says, okay, what numbers do you want to calculate the average of? And the first one, Melinda, is underlined, kind of helping me, saying, okay, you need to type in at least one number. Now I could click on K1 or K2 and then K3, or I could just select this range and it automatically puts in K2 through K3 as a range, and all I have to do to finish the equation is type in the closing parentheses And now it kind of gives me a chance to review it. I say, yeah, that's what I want, and I'm going to hit enter, and there it's back. Another way to do an equation, let's say I wasn't sure how you calculate average. Do you type in equals average or what? Now I know that it's not going to be equals average because Excel didn't finish anything. If I type in equals A, it'll suggest all these different functions it could be, and then V. But if I type in average with AVG, Excel says, nah, there's nothing that begins AVG. So let's say I don't remember any of that. All I remember is I need to calculate average. Well, the moment you type in an equal sign up here in the formula bar, it will suggest stuff. And over here on the left, if you put your cursor over it, it'll tell you a tooltip, which is this is functions. And it gives you the most common functions. If you click this drop down box, average is one of the most common functions. And the nice thing about using this is if you click on average, it opens up this nice dialog box for you, which is really explanatory. And I like using this because sometimes I forget with complicated functions, like, well, what number is supposed to go after the comma, like if statements. So it says, all right, well, what numbers do you want to take the average of? You can type in as many as you want. In order to use this function box, you could either type in here K2, right? K2, and then you say, and then what's nice is it tells you over here, is this really what you want? In K2 is 18.47222. Well, here it's rounded to 18.5, and then you could type in the next one, and it'll let you keep on typing in a zillion, because of course you can take an average of a zillion. The second one would be K3, right? K3, and then it gives you that number there, just kind of double checking, is that really what you want the average of? K2 and K3, yes. I don't want to take an average of another number, so I'm just going to ignore that. And what's nice about this function box too is it explains, and then it gives you the result already, so you can see if you know that's not the result you want, you know you did something wrong. And you can even click help on this function, which opens up the help box, but we know what average means, so we're going to click OK, and there's 20.5 back again. So there's a few different ways, like anything in Microsoft, of typing in these different equations, and I really like this way of using this function box because then it opens up that dialog box that helps you through it. Now let's say we wanted to do something else, for example max and min. You could find those the same way, and we'll show you those in the next spreadsheet, which is PM10 data from the Seldovia Village tribe. Okay, so what we see in front of us now is the sheet that contains the PM10 data from the Seldovia Village's project, in which they gathered data at two locations, on the Mile 2 road and the Mile 4 road, over this past summer using a dust track that continuously monitors for PM10 and spits out results every half an hour. So what the hardworking people in Seldovia did is basically take all the values from these days when the dust track ran at the two locations and average all the results for a daily average. So what we have in front of us is the date from June through September, and then the values at the two locations for PM10 in micrograms per cubic meter at these two locations. And then also Tracy was able to obtain percent relative humidity values for these days and try to get an idea about why the PM10 values were higher on some days than others. And her idea was that, well, obviously if it's very dry, there's going to be more PM10. And so we've plotted that as a third series here. So using this, there's just a few things I want to demonstrate to you about Excel here. So first of all, Excel likes best to make graphs when you've got your first column, which is what you want in your x-axis. And whenever you're plotting something against time, you usually want time or date along the x-axis. So then it goes along and it shows how the values change over time. And so that's why date is first. Then you've got these different values that are going to be plotted as different series. So what this chart shows, and again, if we want to click on one of these series, so let's click on to try to figure out what is presented in these graphs. And I'm going to open up this graph a little bit. I clicked on it, and notice when I clicked on the graph, then it took on this frame around it that you can use to pull and make a little bit bigger. And it also, when the graph is selected, it shows you the data, and it shows you what's on the x-axis in purple. And so you can see it starts with 6/12, and that starts with 6/12 here, and then it progresses through the end of September. And then the values that are plotted are in blue. So just clicking on one of these series, let's just say I'm going to click on this series, and you can see that now there's most of the points are selected, but the whole series is selected. And if you put your cursor over, a lot of things in Excel, it will give you what's called screen tips. And in this case, it gives you the identification of this point. So it's in the series mile 2, and Excel just figures, well, she's got a whole column of numbers here, and the top is labeled something in text. So it automatically, you can change it, but automatically it calls this the mile 2 series. And then, so it identifies a particular point by the x-axis, so it calls it point 6/12/12 for June 12th. And then it gives you x comma y for the coordinates of that exact point. So x is 6/12/12, comma, y is 7. And so, you know, if you take the x value and follow this line down to the x-axis, it will hit it at 6/12. And if you take this point and follow it to the left to the y-axis, which it basically is on the y-axis, it hits at 7, which is right because it's like between 5 and 10, a little bit less than halfway up to 10. So now we know, okay, so that's what's happening here with mile 2, and it varies. So it goes from 7, and then the next value is down here at 0, and that makes sense because that's what we see in the data. Let's click on the purple series, and this first point is pretty straightforward. It's in the series mile 4, 6/12/12, and the first value is 0. So it's pretty much at 0, 0 here because you've got 6/12/12 on the x-axis, and that's the first date in our chart. And then the value here, you can see at mile 4, that first date was 0. So that's what is happening here with the purple series. So you can see that the values fluctuate, and then there's this spike here, and the people in Seldovia looked at their logbooks trying to figure out what was happening on this date when the PM10 values went high, much higher, or like maybe twice as high for the mile 4 series than on a lot of the other days. Well, they couldn't figure out, other than that there was some construction, and maybe they were constructing a new laydown yard at that day, and that kicked up a lot of dust. So what's going on with the green line? So let's click on that, and we could see that the series is selected, and then it automatically puts this frame around these values here. It shows us, okay, that's the title of the series, percent relative humidity, and then these are the values. So if you click, or you just hover your cursor over the first one, say, okay, I'm in the series relative humidity, 0.612 is, and then 6/12/12 is X, and then comma y, 71 is y. Well, wait a second. This is at 25 on the y-axis. Well, what I did here is plot relative humidity on a secondary y-axis, which is over here on the right. And you can see that's why we've got this label, percent relative humidity over here. And you can see that tooltip is popping up. And if you take this and you follow this line over to this secondary y-axis, there it is right at 70. So the reason that sometimes we have to plot things on this right side, so to have two y-axes, is because they're different scales. So if you've got values that are up here around 70, 80, 90, then we'd have to have this scale go from 0 to like 100 to plot all these three series on the same y-axis. Then all of our PM would be down here just wiggling, do, and not really wiggling very much because it would be all so squashed down that we wouldn't really be able to see the most important thing we want to see, which isn't actually relative humidity, but it's how these PM10 values vary day to day. So this series is plotted on the secondary y-axis. Now if you wanted to do anything to these series, like change whether you've got the points shown as points or whether it's just a line like I did for relative humidity, you select the series by clicking around, and now I've just selected 1 point. I want to make sure, because you see these little dots around that 1 point and you don't see it anywhere else on this series. If I want to select the whole series, I click elsewhere and then click on the series again, and then you can see if I put my cursor over it, it says the series. So I've selected the series, and then you can modify how this series is presented by going up here. That whenever you select anything in the chart, this Chart Tools pops up way up here next to the title. Click on Chart Tools, and then you've got a few new tabs that come out. The easiest tab to navigate around a chart using is this Layout tab, because then you see all these different objects that are in the chart. So over here it shows you what you've selected. And you can see if you click this drop down, you see all these different things that you could select in this chart to modify. We're going to leave it as series %RH is what we want to be working with now. So what we wanted is, say we wanted to add data labels. Well, you would click this drop down and then it gives you these options. Well, you could add data labels, which would show you, let's just show you what it looks like. Now you have the values there, which is kind of useful, not so much for relative humidity, but it might be useful for other things. If you wanted, so again, we're in Chart Tools, which pops open anytime you select anything in a chart, even the whole chart, and then click Layout, and you have all these different options. So you can select the chart title, you can have the chart title move to different places. If you wanted to, let's select the series again, and we don't want to select the whole, we want to just select this entire series. And then if you wanted to look at, for example, how the points are presented or different colors, I always right click the series and then Format Data Series. Again, formatting is huge in Excel. And then you could look at, for example, this is where you say you're going to plot things on the primary axis, which is this y-axis over here, or the secondary axis. Let's see what this looks like if I change this series to the primary axis. Well, you could see that it squishes all the PM down here because the PM is like from 0 to 30, right? But you get much bigger swings in relative humidity, and that's way up here. So it's really a situation where if you wanted to look at it and say, well, is the relative humidity high when the PM is low? in order to do that most easily, you would want them on a different axis, so then you could really see the swings in them and not have the PM squished down at the bottom. If you wanted to have markers, right now you see I just have this smooth line. I have none. If you wanted to add markers, then you would say automatic, or you could say, well, I want my markers to be different shapes. If you wanted your markers to have a different color, you could say solid fill and tell it what color. You could tell it to have a different kind of line. You might want to have a line, let's say that's green here, but let's make our line dashed. A lot of times having a dashed line shows that like this is more supplementary information. So if we wanted to have our percent relative humidity, we could make the line of different thickness, or we could make it be like a dashed line, and then you see how it makes that line a dashed line. I actually like it just like a line, so I'm going to leave it like that. But this is how you change the format of this so it looks different with different colors, different dash types, different thicknesses of line. I'm going to say close. So now we have seen what is on this chart. Let's see if for example, does this percent relative humidity add a lot of information? Well, it does, in that we've conclusively seen that it doesn't really have an effect, other than here clearly it looks like, whoa, it got less humid, so drier, right at the same time PM went up. But there were other times when humidity was pretty low too, and PM didn't spike up like that. So the issue, I think, is that it's just so nice and humid there. It doesn't swing around like it does here in Arizona, where the humidity could go down to 3%, and that might have a larger effect. But of course it never gets that dry in this region. So another thing that could be plotted, if Tracy could get the wind speed, that might be really useful, and we might want to look at wind speed. But this does give us information in that it effectively rules out humidity as a real important factor in why PM varied a lot. So there's another thing I want to show you, which is summary statistics. So in addition to what the concentrations were on various days and how they varied and compared to other days, and how the two locations varied together, which they did pretty well even on this spike day. So whatever kind of construction was going on, it affected PM concentration widely. It affected PM concentration at both these locations, so probably anybody who was in that area between these concentrations or nearby, they suffered the effects of the high PM at this time also. But what people are interested in are things like average and min and max. So if we want to generate summary statistics, let's look at the bottom. Now, first of all, remember, if I scroll down, I don't see those headers, and I don't remember which column is which. So while I'm going to be doing that averages, I still need to remember which column is which. So I'm going to go to the View tab, and then I'm going to say Freeze Top Row. And then when I scroll down, I still see these headers. So if I want the average of all the PM10 concentrations over this entire monitoring period from mile 2, I click here, and now we could either just type in equals average, open parentheses, and then Excel starts prompting you, okay, what's the numbers that you want? And if you want, you can click here, and then holding your left click down, pull it all the way to the top. You don't want to include the text here at the top, but go all the way to the top, and you could see then automatically Excel fills in B2 through B37, which is the data we want. And then I type in right parentheses, because then Excel has to know this is the end of this range, and enter, and then it takes me back down, and you could see that the average from all this data is 7 micrograms per cubic meter. And if I click in here on the formula bar, then again it shows me this nice set of data here, how it looks as a color block. So I'm going to click escape because I don't want to mess up my nice average formula. Now what about min? Well, let me show you another thing that Excel has built in. So I click on the Home tab, and over here is a function, this is in the editing chunk, called auto sum. Well, we don't want the sum, but if anytime you see this triangle, there's a drop down list and there's different functions. I could have used average here or count. I could just count the cells that have numbers. We're interested in min, so I'm going to click min, and then Excel guesses. And that's the thing about Excel, you always have to check, because it's guessing wrong. It's just picking all the numbers up until that header. So B2 is right, but then B38, and you can see because it's showing you the data here with this kind of blue flashing light, it's including that row 38 that we just added, which isn't a new data point, it's the average. So to correct that easily, you can click up here, backspace, 7, and then enter. Well, it's minimum. We could have told you that by looking through here, and you could see there's at least one 0 value, so that's going to be the minimum. And now for maximum, there's different ways you can do that too. You can just type in equal max, or you could go back here to this auto sum and say max. And then again, it's guessing, but it's kind of dumb. You can see what it's guessing. We don't want to include these last two that we just added. So I'm going to change that B39 to a B37. And you don't have to type in caps. Excel knows that you mean B, whether it's lowercase or uppercase. Hit enter, and that's the maximum. Now, think of these formulas as stamps. And for these relative reference formulas, and we can talk in a later webinar about the difference between absolute and relative references. When I say reference, I mean this cell is referenced by B38. So think of these formulas as a stamp. So what you're saying is that with this formula, I want to take all the values above it up to the header row and calculate the average. So if I copy this formula here, it's going to do the same thing. It says, okay, I'm going to take all the values above it up to the header row and calculate the average. So let's do that. What I can do is, again, you see this box appears in the lower right corner when you've selected a cell. You put your cursor over it, it turns into a black cross. You hold your left click down and you can drag it over, lift up, and now it has calculated the averages for these other columns also. Let's just check. And if you click in the formula bar, it shows you this block in blue, which is great, C2 through C37. Let's look at relative humidity. Yep, D2 through D37. That's great. You can also copy over several formulas. So I want to copy over the formula for min and the formula for max, so I've selected those, and now it's like I'm copying these two stamps over, holding my left click down, lift up, and there the minimum and the maximum are shown. Now I don't really like all these significant figures here, especially for relative humidity, because we really don't care that much about, I mean, not to mention that maybe they couldn't even measure relative humidity to that exactitude. So I'm going to show you one more thing, which is Format Painter. So remember, first of all, we could change the format of this to show just an integer by selecting that cell, then going over here, and I'm in the Home tab, going over here to Format, Format Cells, And then remember, we looked at this with date, but we want this to be number, and we don't want any decimal places, so I'm going to change that to 0 decimal places, and I say okay. All right, so the minimum relative humidity was 62%, which is probably like really humid for me here in Arizona. I still don't like the way the maximum is with all these significant digits. So I don't have to go through that rigmarole with clicking format and then format cells. I'm going to use Format Painter. So I pick a cell that I like the format of, and that's the one that we just said, no, just show an integer with no numbers after the decimal. I'm going to select that one that I like the format of. I'm going to click Format Painter, and now you can see it's orange, and the Las Vegas lights are blinking around the format that I'm going to copy from, and you see my cursor has a paintbrush now. So it's telling me if you click on a cell, it's going to change it to the same format as this one that you've got these blinking lights around. I click on that, and yes, so now it's an integer. So that just is easier to read, and it's less confusing. But be careful, and remember, the date, it's not like you've gotten rid of all of those. It's still in there. If you want Excel to show out to 10 significant digits, then you just change the format and the data is still in there. So this is a really useful chart because, again, it shows date on the x-axis and then 3 series. And 2 of the series, the PM10, are plotted on a primary vertical axis. So this primary y-axis over here, but then the relative humidity, because these values are so much higher, that we've plotted the relative humidity on this secondary y-axis over here. Now, I lied to you. There is something else I want to show you, which is autofilter. So if you click on, let's say I want to look at only the values that are in July. So I first select all my headers, and this will only work if you don't have big gaps in your data. It has to be a big chunk of contiguous data. Then you go over here to sort and filter, and filter. And then you see you've got these drop down arrows. And now what Excel will let you do, if you click on one of these drop down arrows, you can sort the data and you can also filter it. Excel knows this is a date column, so it gives you these options. Like, do you want to just show the data next month, which doesn't make sense for us, last quarter, last year, year to date? Or it also makes it easy by showing you the values that are here and saying, well, just uncheck the ones you don't want to see. I'm going to uncheck select all, and then I'm going to check July, and now it will only show values in July. I click OK, and you could see that because we filtered out values, there are missing row numbers here, and the row numbers are now blue, which is a hint that stuff has been filtered out, right? All the stuff before July and all the rows after. They're still there, and Excel's telling you that by these rows being, the row headers being blue. And then you can see this, the header for date, where you filtered the data based on, has a filter that shows up in it. And the other thing is that the chart got squashed, because when we filtered out these rows, it also filtered out the rows where that chart is appearing. But because we anchored the chart at the top of the page, we haven't lost it. It's not been all squashed. So that's one reason why if you make a chart, make sure to drag it to the top of the page. And you can drag a chart just by selecting it and dragging it around. Make sure that it's anchored at the top of the page in case you use filtering and then you filter out rows and it looks like your chart disappeared. It is squashed because we filtered out some rows where the chart appears, and you can see it just, what's so great about this technique is it just plots the July data. To clear that filter, we go back here and you just say clear filter from date. Now if we wanted to look at, for example, we wanted to see, well, did relative humidity have an effect? Like, if the relative humidity is really low, does that mean that our PM might be higher? So let's click on this down arrow by percent relative humidity, and now we're going to do a number filter. We could either just like uncheck all the boxes where the humidity was high, but if we wanted to, maybe we've got a ton of these and we don't want to go through click, 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 click. Let's click on number filter, and it gives you these kind of built-in options, and we want when the relative humidity was low. So we're going to say less than, and then it opens up this box, and you can put in different conditions. I want to show rows where the relative humidity is less than what? Well, I don't really know what the relative humidity varies between. I could say 50%, but maybe it's always higher than 50%, right? So I'm going to click this down, and now I see these values, and I can pick one that's in the middle. I can see, okay, it varies from 62 to 93. So I'm going to pick one. Let's pick 80. Or if you wanted, you could type in 81, whatever you want to have as your filter. Then click OK, and you could add more conditions, and more of these rows would pop up down here. But this is all we want, where the relative humidity is less than 81%. Click OK, and now you can see that there's a filter that appears in this percent relative humidity column that shows that this data is filtered out, and you know that because over here you're missing rows and they're blue, and it's based upon something in this column because this is where the filter appears. So and then the chart also adapts and only shows the data that's in this filtered set. So is it true that when the relative humidity was lower than 80%, the PM was higher? Well, it doesn't, yeah, it's true, the spike is there, but it doesn't really look like, oh, they really correlate well. So I'm going to remove that filter just by clicking Clear Filter. So we've gone over a lot of topics, and thank you very much for joining us on this webinar about Excel.